So you are welcome to our second lecture, second major lecture on financial management. And today we want to look at the time value of money. It's a very interesting course, but the focus is not really on the time value of money, but actually to calculate the final values of annuity. So that is what majorly you will be looking at: final values of annuity and sinking fund and all those things. It's purely calculative. So, and you need to read the question well. You also need to really understand it's formula based, and in financial management, you are given formula table. You are at the back of your paper. There are a whole lot of formulas there. So you have some of the formulas, but the way they quote the formula is not the way that is so clear and easy for you to use, unless you are somebody who are into econometrics and all those mathematical quantitative analysis. Yes, other than that, you have to stick to the formulas that we'll be doing here. Learn to be using them consistently so that it can be on your fingertips. Now, we start by understanding why we are learning this, because there is a concept called time value of money. And the whole thing is, those of you who have done interest rate parity and purchasing power parity and all those things, we will do that when we get to risk management. But now, the whole issue is that if I'm promising you money, so Christabel, let me ask you this. You have a choice to take 1,000 Ghana cedi I'm offering you today, or 1,005 Ghana cedi I'm giving you next week. Which one of these offers would you want to take? 1,005 today, 1,000 today, 1,005 next week. Which one would you go for?
1,005 next week.
1,005 next week. I see. Let me pick another person. All of you are males apart from Christabel. Makafui. Yes, Makafui, if I'm giving you 1,000 today and 1,005 next week, which one will you go for?
I'll go for 1,000 today.
1,000 today. Okay. So the two of you start giving me reasons. Starting from Makafui, why will you choose 1,000 today?
Because I'll choose 1,000 today because currently the value of the 1,000 cedis will be much more higher than the value of the 1,005 next week to me.
In fact, I won't even go to the next person, but okay, you let me go to the next person. But you have just spoken like a Ghanaian. That's the sincere truth. I will explain to you why I said that. I say, Omanenya dia won is a be that should be anytime soon. Okay. All right, Christabel. Why would you choose
I'm
1,005?
choosing the 1,005 because maybe I don't need the 1,000 today. So 1,005, I feel like I've gotten another 500 Ghana cedi, like an addition.
Yeah, that's fine. But the two is fine. But from Makafui's perspective, and that is the perspective we all share because we are all Ghanaians. Today, fuel is how much? So, so fuel is like almost 13, right? Now, if you get 1,000 cedis today, the value is as it is, like 13 cedis a liter, no problem. But the 1,005 next week, I don't know if Christabel, you've heard that the Trotro people have issued up a statement that they want to increase transport fares by 20%.
Yes,
So,
yes, I have.
So you see the value, that 500 you think you have on top of the money, by the time that 500 gets to you, prices have also increased. So you realize that the value of the money, the nominal value of the money, yes, have increased to 1,500, but the purchasing power of the money is the problem. So one of the things is that I said I'll give you 1,500 next week. But what if next week come and I tell you that, oh, my mother needed money, so I had to give the money to my. You've lost it. That's the meaning. But the one who takes the 1,000 now has gotten the money. So that is what this concept is about. So you see here that we said that money today is worth more than same when received in future. In this case, I even topped it up with 500 cedis for you. But if you have 1,000 today, 1,000 tomorrow, the best to go for is actually the 1,000 today. That's what you need to go for. Yeah, because number one, there's a potential interest that will happen. Interest. Number two, impact of inflation. Number three, effect of risk. Risk being that all right. So that is that. And I've explained the potential interest earnings here. All right. So you have the slide. I don't want to do reading, sir. Okay. You have the slide to read. Then the impact of the inflation is also here because we've talked about that. Prices are going to increase over time and you will lose the purchasing power of the money. All right. Then the risk is also there. There's a less chance of something happening such that the money cry, you will not even receive it. So I said that there is a less chance that events will prevent payment. All right. It's supposed to be there's a more chance, yeah, that events will prevent the payment. All right. Now that's that. But I think you get a picture of what I'm trying to talk about. All right, because like I said, my mom can call me and tell me that she needs the money. It doesn't matter. I've promised you. I'll give the money to. I'll give the money to my mother. All right, so that is that. Now, then we come to talk about concept of simple interest. Please, I know you know simple interest. Is there anybody here who doesn't know how to do simple interest? Let me know because I'm going to skip it. Is there anybody here who doesn't know how to calculate simple interest? Please let me know. All right, that's fine. So simple interest is just taking the money, find the interest means that you take the principal, apply the rate. Then please, key point number one of everything we are going to do here is something you need to know. And it is, you don't need VAR for this one. Rates are quoted per annum basis. All right. Unless the question actually says something so peculiar about it, every rate that you see is per annum, unless the question actually says something so peculiar about it. All right. So that is that. So all you need to do is to pick the amount and multiply it. So in this case, look at this one. Let's say a student obtains a simple interest to pay one year college tuition, which costs 18,000, and the annual interest is 6%. Then the student repays the loan over 3 years, which means that there will be interest of 6% for 3 years. So that tells you that if the money that he borrowed is 18,000, then it means that you are going to apply 6%. Now, if the loan is for 3 years, then it means that you need to multiply by 3. Now, we are saying that interest is equal to what? Principal times the rate times time. So the time is expressed in years. All right. If the time is one month out of 12 months, then you do 1/12. I mean, these things are things that you know. So there's no problem around that. Then we come to the main oga. And this main oga is what you need to be careful about. The main oga here is the compound interest. All right, the compound interest, where the interest is compounding. Now, the concept here is not that you are actually paying double interest. No, that is not the meaning. It's not times 2 interest, it's compound interest, meaning that after the interest, that if you get the interest is now added to the principal, then you get a new principal amount, which is the old principal plus the interest that you earn. Then you recalculate the interest on that new amount. So that is how it works. That is how it works. But please, if anything at all, as for the simple interest formula, that is what we are going to be using in this 10-mark course. So please, as for the compound interest formula, you need to learn it. And it is not difficult. You are just, this if we are doing it for the amount, so the amount that you are paying, all right, is the principal that probably, let's say, you borrowed or you invested, plus 1 plus R. This is it, raised to the power n. That's all. That is the compound interest formula. However, we need to find out the number of times the thing is compounding. So you will see that here there will be t here, and here there will be t here. Forget about the fact that here you see it as n. It's a variable. The only thing you need to do is to make sure you understand what each letter stands for. All right. So that t here will be the number of times the thing is compounding in the year. Number of times it is compounding in a year. And please be careful. We will need this thing. Seriously, we will need this thing. And the n here is the number of years. And this t is the same as the t here. The number of times the thing is compounding in a year. All right. So please take note of that. So we have this number of time of compounding in a year. Please take note of that, in a year. Then this one, this n, is the number of years, all right, of the loan. All right, so that is that. So that is what you need. Now, when you get that, you get the A. You get the A. So if you want the compound interest, then it will be CI, which is the compound interest. The amount minus what? The principal. The amount that you've calculated for minus the principal. That will give you the interest. All right, so that is that. All right. So please take note of that. We are going to apply these things soon. As for the formulas, I want you to get them. All right. I want you to, and I've given you this slide before, so I expect that you've gone through it. All right. Now watch this. In our earlier example of the student paying 18,000 with an interest of 6%, let's say the interest is compounding. So what do? You see, the first year, the 18,000, you will pay a rate. Now, whenever you are doing this, key point number 2 is that check the date or check the timing of borrowing. Now, watch this. This year, assuming the person borrowed the money at the last day of year 1, do you think there will be an interest calculation? Class, assuming he borrowed the money on 31st December, do you think that year there will be an interest calculation for that, the money that he took? Hello? Please, this is an interactive class. So I expect you to give me responses. Unless there is an issue with the internet. Hello, please, are you there?
Hello, sir.
Yes, sir, we are here.
Yeah.
I need answers to my question.
Sir, please, the line was breaking from my end. If you can repeat yourself.
I'm saying that if you borrow money from a bank on 31st December, let's say 31st December 2022, would there be an interest for you to pay in 31st December in the year 2022?
No, sir.
Hello, sir. No, please.
Why?
Because is the year has already ended, so I think interest will be paid in the following year, but the current year has ended.
So that is something I need you guys to take note of in the exam. So be careful. So check the timing of the borrowing. So in this example, for instance, it is assumed that the person borrowed the money at the beginning of the year, because that is the only way you can calculate a full year interest on the money. So please always check those things. Now, the principal is 18,000. The first year interest, this is what we have. Somebody should compute it to check the correctness. 6% on this, check the correctness. Then year two's interest will actually be on the interest plus the principal. So this is what you get. Then you calculate, it's rounded. Then you get this figure. Then you go on. That is how the cycle goes on. Please, is that okay?
Yes, sir.
But with this thing that we've done, you can actually use the formula to land you at the amount. And that is the formula that we learned over here. So if we want the amount, so you see this final value, this year 3, it is assumed that this is the end of year 3, not the beginning of year 3, end of year 3. And so the timings at both ends, you need to be very, very careful. Spot those ones, because if the person is taking the money at the, is the thing ends at the beginning of the year, it means that in the 3rd year, the person will not pay any interest, because the money will not be there to run through the year for the interest to be paid. So please, these timings, the time the loan is taken and the time the repayment is done, these are 2 timings you need to be very careful around. All right, so please be careful. Now, so we said that the formula can help us. The amount is 18,000. And we said that it's 1 plus R N. How many times is it compounding? It's just once in the year, so it's just R. All right, then we bring N. The T is also 1, so it's just the same. So we will say that 18,000 into bracket 1 plus R is 1.06 raised to the power how many years? 3 years. And if you do that correctly, you should be ending up this same amount, 21,439. So that is it. And that is what you see here. That is what you see here. And like we said, if you want the compound interest out of it, then it means that the amount that you've gotten minus the principal of 18,000. If you do that correctly, you should also end up here. So that is part of the formula. That is this part of the formula is what we actually call the compounding. All right, that is the part that we call compounding. So if you check your slide, I've made the explanations there for you to see. So that is what we call compounding. All right, so and these things these are the basics of it. We are getting somewhere, and these are the basis of it. So I think you should be able to understand these ones with apt speed. All right, so that is that. Now, at some point in your exams, you'll be asked to calculate the effective rate and the nominal rate. And you need to be careful in terms of dealing with that. If you want any rate, ER, you see, the effective rate is simply the interest over the principal. That's all. That's all. So if they ask you to calculate the effective rate, then it means that how much interest amount, how much are you paying? Then you divide it over there. So like the example that we did, let's say how much was the principal? 18,000, right?
Yes,
Is it 18? Yeah, and and how much is the interest? So let's go back.
Yes, please.
So this is the interest. Can you compute for me the rate, the effective rate from that? Can somebody compute for me the effective rate?
0.1910. We should take it to percentage.
Yes, please.
Okay. It's 19.11%.
19.11%.
Yes, please.
That is how much the person is paying for the 3 years. For the 3 years, Abi. Hello, are you there?
Yes, sir, for the 3 years.
So if you spread it over the 3 years, what will be the rate?
So over the 3 years, each year will be 6.3.
So we are around that 6% per
Yes,
annum.
sir. Yes, please.
Oh, okay. So that is that. That is that. So it did what? 3,439 divided by how much?
18,000.
18,000.
And you had 19 something. Then if
0.11.
you spread it, then it means that we are having 6% and something percent.
Yes, sir.
All right. That's that. Okay. Okay. So that's it. Now let's move on. So we move on, and I've already explained to you all this compounding effect.
Hello, sir.
Any
Please,
question?
a question.
Yes, please.
Yes, please. So please, when you are being asked to calculate for the effective rate, it means that you have to find a rate per annum, not per
not
the number of.
necessarily per annum.
Okay.
Not necessarily finish it and divide it. Once you are done, you are done.
Okay, sir.
You found your interest, you are done. So what you've done is that you found the cumulative percentage of interest the person is paying. But if you multiply that cumulative percentage of the person's payment, you know that the person is going to spread the payment over the 3 years.
Yes, please.
Yes, so that is what it's about.
Okay. Thank you very
All
much.
right. You're welcome. So now, there are some examples for you to see. I have this example about the nominal and the effective rate. So you saw that the nominal rate the person was paying was like 6%, but effectively the person is paying like 19% or something. Yeah, so that is what you gave me. All right. So when we say the nominal is just the face value of something, okay? That is it. So the nominal interest rate is the interest rate without inflation. It is the interest rate for which inflation has not been inculcated in. But the effective rate is having inflation inculcated in the interest rate. So we are going to do some calculations very soon. But I just want you to understand the difference between the nominal and the effective. All right. So the disadvantage of the nominal is that it doesn't bring in inflation, and the truth is that inflation is inevitable. Yeah, it's inevitable, especially in Africa. Inflation is inevitable. Now, a typical example of finding how to calculate the interest rate in terms of the effectiveness and the nominal is this example. But watch the example well, because I've bolded some parts. Watch it well. It says that a trader wants to borrow 1 million Ghana cedis, and he has been offered 2 loans. Look at the loan 1. The loan A charges 10% per annum. And the loan B 5% per every 6 months. So it means that every 6 months. So it didn't say per annum, it said per 6 months. So which loan should the person take? You realize that in the loan A, this is it. And we are learning compounding. So please, the underlying assumption is compounding. So take note of that. Now, if it takes the 1 million in loan A, the interest is just 10%. So this is 10% of the money when you do 10%. And so at the end of the day, this is what the person is paying. The amount from the interest. All right. So this now becomes the new value. So if you want we will come to that. I'll show you the interest calculation very soon. But look at this one. The person is paying 5% for every 6 months. So the first 6 months, you pay 5%, and 5% is this one, which you add it up, you get this. So the next 6 months is the rollover. So somebody should compute the next 5% on this one. 5% on this one, then so as to confirm the figures.
52,500.
So that is what you have here. All right. Now, when you check the interest that the person is paying, here he's paying this one. This is the amount that he's paying. 100,000. But when you check for in the year, this one is 50,000 plus this 52,500. So he's paying this money. So that is it. Now watch this. Watch this. It tells you that the interest for this one is higher than this one. A lie? It's higher. But look at it. And this is what they do to our mothers in the market. Oh, 5%, 10%. On the face value of it, you will not take this one, the 10%, because you say the 10% is higher than the 5%. But you will not even consider this part of the equation. You are bent to say, oh, this one is big, and so let me go for the small one. So you will take that one. And you see, you are rather paying the higher interest. So that is what we are talking about. So given that, we now learn how to calculate the effective rate and the nominal rate using this formula. So this is how you can use this formula for the effective rate. And with that, when you do it, this is where you are ending up to. So technically, now somebody should also do this like the way we did. So what we did earlier, take 100,000 out of 1 million. Let's see your answer. Take 102,500 out of the same 1 million. Give me your answers now.
So the first one is 0.1.
The first one is 0.1.
Same as 10%.
And the second one is what? So 0.1 is 10%. And this one is what?
The second one is 0.102.
0.102. That is 10.2 something, right?
Yes,
sir.
please.
Don't you have 5 at the end of it?
Yeah, 10.25%.
All right, so that is that. So like the formula I gave you, ER is equal to what? The interest all over what? The principal. Please understand this, because this thing came to their exams last 2 sittings. Okay, it dropped in their exam last 2 sittings. So find the interest divided by the principal. That is how you get your answer. All right. So please, any question before we move on to final values? Any question? It's easy, Abby. Somebody says, when it is examples like this, it's always easy. But when it is exam, then the spirit comes. All right, now let's look at this example. We want to look at final values of series of payments. Okay, now watch this. This is year 0, i.e., it can be any year. Then we have 1, 2, 3. So we have year 1, year 2, year 3, then year 4. This is today. So in finance, you will see words representing 0, year 0 as today, now, immediately. All right, all these things are words that symbolizes today. Okay, so that is that. Now I'm in today, but I want to save some money to have an amount in, let's say, year 4. So let's assume today is 2023, right? Today is 2023. So 4 years time will be what, 2027? Or guys, let me hear. I want you to be active. 2027.
Yes, please.
I want to buy a car. All right, here, but I want to save some money so that in the next 4 years I can actually buy the car. Now watch this, and that is the example that we are showing you here. In fact, you first have to understand that, okay, so I'm saving the money today so that it will generate interest. Now, when it generates interest, the interest will be on my principal. The interest will be added to my principal. Then I will roll it over. Don't forget, we are still under compounding, okay? It will be rollover and it will be rollover. So that is how it will be. Sorry. But today, I told you that you need to understand which day, which part of the year is today. Is it the beginning of the year or is the end of the year? So let's say it is the beginning of the year. So I put in 10,000. All right. Now, then I need the interest rate. The interest rate is 10%. All right. So that is that. And you see it in this example. Ansa invest 10,000 per annum. On the first day of the year, it's very important you always check those things. 10%, 3-year compounding annually. All right. And compounding annually means that it is compounding only once in a year. Once in a year, compounding annually, once in a year. Now, you see, you remember the formula? A is equal to, who remembers? 1 plus R all over N. This one, N is 1, right? What is N? What did I say N is? Hello? N. What is N?
Compounding in a year.
The number of times the thing is compounding in the year. In this case, it is compounding annually, so it is once. So it means that if I can stand in here and say that, okay, the amount is 10,000, 1.1, right? 10%. That is the amount of time it is compounding. Then I put the number of years, N. So T is time. Okay, I could have also said here is T. All right. So here is T. And N will be the number of years. So if the number of years, then we are using 3 years here. So it is 3 years. When you do it, how much will you get? What will be the amount so that we can find out the interest?
Say 13,310.
13,310. 310. Somebody should also confirm.
So it's correct.
So it's 13,310. All right. 13,310 is that is the amount. So that is the A. So what will be the compound interest? 3310. Is that it?
Yes, please.
All right. If what you said is correct, then let's confirm. So I invested 10,000. Then first year, I'll get 10%, which means that my money will be here. All right. So this one is correct indeed. Now, let's look at another scenario. And the scenario is this particular question. If you watch the question well, it said Ansa invest 10,000 cedis per what? Per annum. Did you see that part? So it means that every year he will still be investing 10,000 again. So what happens is that if that happens, the formula changes, and I will show you the new formula. Oh, I've already even brought it up for you to see. I wanted to show you, but no problem. You see, let's do the normal mathematics for a beginner. In the normal mathematics for a beginner, since Ansa is investing 10,000 every year, the first year he will get interest of 1,000. So this is the money. Then he tops up again with 10,000, right? In the second year, which means in the money that the interest will be calculated on will be how much? 21,000. I hope you understand that. Then you calculate another 10%, and this is what you get. This is it. And he will now put in another 10,000. So the money becomes this, and therefore the 10% is also this. Now, which tells you that every 10,000 that he is investing is on the first day of the year. Please, and that thing, be very, very careful. Very, very careful. The timing of the payment. All right. So the finance people have sat down and given us a formula that, oh, instead of doing it like this one by one to land up as this, why don't we put it in a simple formula so that we can actually get the money straight? This is it. And this is the formula. This is the formula. That's the formula. So the formula is as you see here. So it says that you have S, or you can put A. As for these things, you can decide to do it anyhow you want it. So let's say it's S. And the formula is saying that what we need to do is to do A here, and A is the amount, okay? The principal. That the money that the person is paying every month or every year in this our question. So we call it the first term in the time series. All right, the first term in the time series. So that is what you have. Now, what you do is that you do a R raised to the power n. We all know what R is. R is the rate. Okay, so R is what you have. R raised to the power n. Then minus 1. Then R raised to the power. In fact, it's supposed to be the R plus. This is it. The common ratio. Have you seen it? 1 plus R. Even though it is R here, this is the language of it. 1 plus R. All right. Then the same R minus 1. Okay. So if you do that, it says that this one is in a situation where this A is on the first day of the year. First day of the year. Then, if you don't add this one, then it means that the formula, just like this, is going to give you the answer also at the first day of the last year. But if you want how much you will get at the end of the last day, then you add. Yes, please. Emmanuel, go ahead. Ima, go ahead. Hello, Emmanuel, your hand was raised. Hello, Emmanuel. All right. So that is that. Please, these are the these are the parts that things start getting interesting, and I need you to be very, very careful. So the formula is assuming that the money indeed is at the first day. And please, this is it. The sum of investment at the beginning of each year. So that is that at the beginning of each year. So that is what you have. And if you don't add the 1 plus R, then it means that the money that you've gotten, which is the S, is going to be the one at the beginning of each period. But if you want it at the end of the period, then you further push it 1 plus R to the end of the period, where R is the rate, all right, to the end of the period. And this example, since we wanted to know the final value at the end of the third year, not at the beginning of the third year, we have to continue with another one, 1.1. So please, that is that. Had it been that the question has asked us how much the money will be at the beginning of the third year, we won't add this part. We won't add this part of it. Please, have I made sense? Hello, class, have I
Yes,
made
please.
sense?
Yes.
All right. With that in mind, then it means that we won't struggle. We now go on to this place where they examine all the time that brings confusion to students. And we are going to use the same formulas that we've been using. All right. So this formula and this formula is two key formulas. So what we are doing is that we are calculating the final values of an annuity, final values of an annuity. And please, the annuity we are talking about is not the annuity that we use when we are doing PV, NPV, and all those things. There is an investment package called an annuity. Understand that. So when we say the final value of an annuity, we are not talking about the ones that you do a series of equal. It's the same thing, but what I mean is that the concept of an annuity here we are discussing is an investment package. Okay, so look at this. An annuity is a financial product or a contract. So that is what we are looking at. So we are not looking at discount factors. We are looking at the financial product. So an annuity is a financial product that provides what series of regular payments to an individual over a specified period of time. So we are talking about investment package. So a typical example is your SSNIT. Okay. So the SSNIT you are doing is an investment package. What you are doing is that you are paying some money into SSNIT. At the end of the day, they will also be paying you some money back when you are in retirement. And the retirement money that they will be paying you back is going to be a series of regular payments. All right. So over a specific period of time. So that is what we mean. So if they are going to pay you 10,000, 10,000, 10,000, 10,000 every month, that becomes the series of payments. And the series of payments here is a series of equal payments. All right. So please take note of that. So we said that it is typically used as a form of investment or retirement saving vehicle. Just have explained to you. So an annuity is offered by insurance companies and can be purchased with a lump sum payment through a series of regular contribution. So you can also decide. So there is a contract. So the contract is like this. Okay, pay me 100,000 in 4 years. If you are able to do that, I will be paying you every year. Let's say, how do I go about this? I'll be paying you 30,000 every year. 30,000 every year for 4 years. So that is it. You first pay me your 100,000 for 4 years. So in the whole 4 years, pay me for 100,000. When you are done, I will also be refunding to you every year, 30,000. Now watch this. You realize that this one, if you are to pay year by year, is how much? Is it not 25,000? So it means that you'll be benefiting some 5,000 extra every year from that investment package. So that is a typical example of how an annuity is. So like your SSNIT, you are paying money every year for them or every month for them. When you retire, they will also be paying you some specific money. So now the question is that how much should you put in every year over here so that you will land at this 100,000 for the 4 years? How much? Yes, who can tell me? How much do you need to, if the annuity package is costing 100,000, for 4 years. Every year, how much should you put there so that you will get 100,000 in 4 years? Yes, who can tell me? Hello, class. Should I call names now? Christabel, I'm on you. If I need 100,000 4 years time, how much of equal payment should I be making every year so that in 4 years time I'll have the 100,000? Yes, Christabel.
So 25,000.
It's as simple as that. 25,000. 25,000. Because it's there, people are confused. You see, then they bring something into the equation. They tell you that assuming interest rate is 10,000, compounding annually. How much should be invested annually so that Christabel can purchase the 4 years annuity of 100,000. So Christabel, now the dynamics have changed. You see, when you said 25,000, it meant that there is no interest rate. But now there is an interest rate. And you see, it will be compounding. So if you put in 25,000 and there is compounding on it, okay, of 10%, which means 2,500, and it rolls over, you see that when it gets to the 4 years, you'll be having more than 100,000. Do you agree? Do you agree?
Yes, please.
Yes. But here, what we are doing is that we want the amount that you can invest on equal installment. And please, at the beginning of the year, timing is very key. Assume Christabel invests at the beginning of each year. Yes, so now, so Christabel, let's do some mathematical analysis here. And please, I want everybody's attention. Now, let's use your 25,000 first. And I'll show you something. So let's say you did 25,000 first year. You have 10%, right? Which will be 2,500. Here will give us what? 27,500, right? That's it, right? Then you invest in year 2, you put in your 25,000 again. So you have how much? 52,500. Is that correct? Then we do our 10%, which means what will be our 10%? 5,250. That's it, right? So how much will we get? Here will be 5,775.
750.
Yeah, so that is what we have. Then this is the third year, so you add your 25,000 again. So you get how much? 750.
82,750.
It's what? 82,750. All right, then you do 10% of that. What would you get? 8,275. So how much will we have?
91025.
91025. Then on the 4th year, that you are doing your investment at the beginning. So the 4th year is what? 25,000 again. You see that you've already gone over the 100,000.
Yes.
So it means if you invest 25,000 every year, you will be over the 100,000. But you want a specific amount that you can invest that can land you exactly at that 100,000, the exact 100,000. How would we do that? How would we do that? So that is what the question is always about. In your exam, that is exactly what the question is about. It's just that they will bring in number of times the thing is compounding. Sometimes they will say it is compounding 4 times in a year. This one we are doing is just 1 time in the year. All right. So that is that. Now, so in order to deal with that final value, you see, it's final values and annuity. So the final value that we want is the 100,000. So how do we know how much we are supposed to be paying in there when the thing is compounded? So we have 2 types of annuity. And please, what we are saying, this is not present value. This is not discounting factor annuity that you know. This is what do we call it? This is a financial product, all right? Understand from that perspective. So we have annuity, ordinary annuity, and annuity due. What is ordinary annuity? Ordinary annuity product is when the cash flows are in arrears. What does it mean? It means that when they are at the end of the period, at the end of the year. Then annuity due is when the cash flows are in advance, i.e. at the beginning of the period. So if you are confused, alphabets, which one comes first? A. If A comes first, then A is in the beginning. If O comes after A, then O is last. Therefore, O is at the end of the year. Please, so that it can be made easier for you. Is that okay? So ordinary annuity is when the cash flows are in arrears, i.e. at the end of the year. And annuity due is when the cash flows are in advance, i.e. at the beginning of the year. So the typical example that we are doing here is a case of at the end of the year. Why do I say that? I'm saying that because we are talking about the final value. We are not talking about the annuity, the where he makes the payment. All right. So that is what we are referring to. To make it even simpler, let me just use an example. So it depends on the time the person is making the payment and the time the person is collecting the money. So here, look at this ordinary annuity. When did we say? We said that ordinary annuity is when the thing is at the end of the year. Have you seen this? When the payment is at the end of the year. Why are we saying that? Look at this. So this is the year. Let me make it better. We will come back to this illustration, okay? We will find the answer. Look at this. So watch this. This is our year. So this is first. And this is 31st. Then we have this. And this is first. And this is 31st. So that is that. Then we have the years in between. All right. So now, when we talk about annuity due, it is trying to tell you that, and please, one thing I must say is also that, one, check the time the person is making the investment. Yeah, I keep saying that. I keep saying that. And I keep saying it, and I keep saying it, and I keep saying it. If I want to invest for 4 years or make the payment for 4 years, and my first one is here, 31st December at the end year, how will you count my 4 years? And if I do it here, annuity due, how will you also count my 4 years? But at the end of the day, the answer that we want is this one. At the end of the last year here. So this is the final value. So now advise me, 4 years. How will I count it? This one. How will I count it? Yes, who can help me?
Listen, if I should try, if it is done at 31st December, then the year of investment wouldn't be inclusive. You start from the following year.
So
but
this
if it should
one?
Be done at the... Yes, please.
No. First, finish the one. Let's count. Let's do the count.
All right. So you just start
it will
from
be 1.
there. Yeah.
Right.
Yes, please.
2, 3. Then if there is a 4th year, 4, right? So let's make it 3 years. Let's make it 3 years.
All right.
Instead of. All right. So it's 1, 2, then 3. But the 3, which part of the 3? Is it the top here or the down here? That is my main focus.
Yeah, so it should be the down.
The down.
Yes, please.
Down, right? Okay, so if it is at the down, then we don't need to do another 1 plus R to get to the down. Are you getting it? If this is our final value, then it means that when we get here, we are done. There's nothing we should do anymore. Did you understand? We want the final value and we are there, so there's nothing to do. Please, do you get it now?
Yes, we are following.
All right. So now, watch the next one. What if you did it here at the beginning here? All right. So it means this part will be inclusive, right?
Yes, sir.
So 1. Let me count from down like this. So it will be like 1, right? 2, then 3. All at the beginnings. Is that not it?
Yes, sir.
All at the beginnings. But what I'm trying to show you is that, so this is 3. So assuming this will be 8. This is our 3rd year. So you realize that if it is at the beginning, it will take you 4 years to get to the final value. True or false? We will need to count another 4. In fact, you will need to count from here to here again. And the year that you will get to, your 4th year actually is even like 5 years. I don't know if you are getting the picture I'm trying to show you. So this is how you count. And please, let's count it well. I think we missed the count. 1, from here to here is 1. I think we missed the count. Here to here is 2. Then here to here is 3. And in this one, this is 3. We use this. Okay, so now this one, we started at the beginning. So yeah, that's it. Here to here is 1. 1. Here to here, you get 2 years. Here to here, you get 3 years. Then you have to do another one to here to get it. But the import of what I'm trying to show you is that when the thing is that the last day of the year, the answer that you get, which is the last day of the year, means that the payment comes at the end of the year. The answer that you get puts you straight to your final value. But when it is at the beginning of the year, the answer that you will get puts you at the beginning of the last year also. So therefore, if you want to get the value at the end of that last year, we need to add this bit of it. Have I made sense? Please, have I made sense? So since we go here as our 3rd, if we want this one, we need to do another 1 plus R raised to the power 1 to get to that year. Please, have I made sense?
Yes, please.
Because the timing is very, very key. And that is what the exams is all about. So you see in this formula, if it is ordinary annuity, this is where you end it. If it is annuity due, which means that it is in the beginning of the year, you need to put it 1 year further, all right, by doing 1 plus R. So S is the final, this is the final cash flow, the final value that you want. All right. Then X is the annual installment. Now let's go back to Christabel, the one that we did. Let's go back. This is the question. So now we know that if we are using, and we are told that Christabel invests the money at the beginning of the year. So which of these formulas are we going for? Which of these formulas are we going for? He makes his payment at the beginning of the year. Which of these? Annuity due. Okay, so if it's annuity due, we know that our future value, don't forget, S is the final value at the end of the loan term. So our future value is already known. So our S is what? 100,000. Which is equal to the X, the annual payment Christabel has to be doing, which we are looking for at the beginning of each year. We don't know. That is what we are looking for. So it will be X. Do we know the interest rate? So 1 plus R, interest rate is 10%, right? So 0.1 raised to the power. How many years? We are looking at 4 years, right? Compounding is also just once a year. So here will be 1. So we don't have a problem. So we have 1 here, raised to the power. Then when we finish, we minus 1 all over 0.1. Please, are you following? This is R, 0.1. Yes. And since it is annuity due, then it means that it will put us to the beginning of the year. And so we need to push it extra 1 plus R. So the 1 plus R will be 1.1. So technically we have 100,000. Somebody should compute and get me the figure. Please capture this picture. I want to come to this part to have a space. So what was the money? So we said we have S is equal to X raised to the power 1 plus R N all minus 1. Okay, all over R. And since it's annuity due, you need to do what? Multiply by 1 plus R. All right, so now we have 100,000 here. We have X, we don't know. We have 1.1 raised to the power 4 years minus 1 all over 0.1 multiplied by 1.1. All right, so now what will be the figure? So this one calls for a little change of subject, kind of. So what do? You first do this part. Okay, so do this part, finish. All right, then let's do the change of subject. Yes. Please learn how to point.
So that part is 4.641.
Here is 4.641. X, right?
Yes, please.
Then we have 100,000 here.
So I didn't add the 1.1.
You didn't add this one?
Yes, please.
So you did this part?
Yes, please.
Okay. All right. You can add it. I mean, you can add it. Because we need to divide, do a change of subject.
Okay. Okay. So please, that one is 5.1051.
I have somebody's on, yeah. So Makafu is there 5.1051. 51 X. Then we have 100,000. Yeah. So now what is X?
19,588.
19,588. So now you see that your 20 point is money, so 2 decimal place.
Yes, please.
0.22.
0.25.
0.25. All right. Now you see that your 25,000 that you gave me, we exceeded the 100,000 figure.
Yeah.
Even the last year, we didn't even calculate the interest, but just this one showed us that we have exceeded. But this one is actually telling us that to get exactly the 100,000 in 4 years, we can actually invest just 19,000, so 19,588, so that the interest that is compounding on it will actually feed into we getting the 100,000. So please, is that okay now? Is that okay now? Class, let me know, because I want to know you are understanding it. If you have any question, ask, okay?
Please, it's okay.
It's okay. Because it's going to get a little tougher and we need a foundation. That is what I'm building on. All right. So thank you. It's good you've gotten this aspect of it. Now, so we found out that the next time maybe the question will tell us that the payment is just the payment is at the last day, then we will know that we won't use annuity due, but we will be using what? Ordinary annuity. So that is that. Now watch this one. Watch this question. Watch this question carefully. Carefully. It says that a savings scheme involves 100,000 per annum for 4 years on the last day of the year. If interest is 10%, what is the sum to be received at the end of the 4 years? So this one, is it annuity due or ordinary annuity?
Ordinary annuity.
Yes, to be able to answer that question, you need to find out what is the starting point of the payment and what is the ending point of the receipt. So you saw in this question, of course, the answer is there, so I won't worry you. But you see that his payment is on the last day of the year. So it means that he's making the payment on the last day of the year. But he's also collecting the money at the end of the 4 years, not at the beginning of the 4 years, but at the end of the 4 years. So it makes it more clear for you to apply ordinary annuity, or because the money is at the beginning. Now watch this. If he was to collect the money at the beginning of the last year, you know that will be a problem. Because we did the reading here, those, if you followed me carefully, that the ordinary annuity, this one, the 4 year, for example, will be 1, 2, 3. And we didn't even do the 4. But assuming this one is 3, and the 3, you see the 3 that we did when the money is paid at the end of the year, the final value that we had was the last day of the final year. What if the thing is ordinary, which means it is at the beginning, the person is paying the money at the end of the years, but he will be receiving the money at the beginning of the last year. So which tells you that, hold on, this one will be then it means that if they tell you you'll be collecting the money here and your ordinary gives you the answer of this one, what do you need to do to get back to this place? What do you think you need to do? What do you think you need to do? If you are getting what I'm asking, let me show you well. We said that in ordinary annuity, we will be like this. 1, 2, 3, 4. An ordinary annuity means that the person is making the payment at the end of the year. And we said that to be able to count at the end of the year, somebody said this part will not be, but we will focus here. And the end of this means the beginning of this. True or false? True or false? Guys, I need your response.
True, sir. True.
True.
All right. Now, if that is the case, we said that we will count 1, 2, 3, and 4. And we all agree that the 4 actually, if you are to look at this thing carefully, if you are really looking at it carefully, because we are looking at this our year, this is the count of our year. So even though the person is here, so it will be 1, 2, 3, but starting from here to make it 4, 4th year. So we said that the answer that we get is actually at the end. When it is ordinary annuity, we need to be careful around it. When it is ordinary annuity. So it means that the answer that we get is at the end. And so if it is at the end, we don't need to add this part, 1 plus R. But I'm saying that if your answer is at the end, which in this question it is, you are having your money at the end. What if in this question, he is making the payment at the beginning, but he will be receiving the money at the beginning of the last year? What do you think we should do? If you have here, your answer is here, but you want the value here, what do you think you need to do? What do you think you need to do? Guys, think. It tells you that we said that in the ordinary annuity, when we had the answer here, what did we do? We did 1 plus R again. Is that not it? Is that not it?
Yes.
So now that we have here, if we want here, what do? We need to actually PV it. So it will rather be A 1 plus R N. You know how to do a PV, right?
Yes.
So if you get here, then you PV it back 1 year. So these are the dynamics of the questions. These are what they trouble you guys with, the dynamics of these questions. So that is that. So please be careful. Be careful. So you can try your hands on this. All right. You can try your hands on this. All right. Then the last part of today's lesson is to also learn how to calculate the, you see, we've been calculating the final values of future, future, but here we want to look at the present value, So the formula changes a little. It changes a little. So look at the present value. So when we wanted the future amount, who remembers? It was like this. If you remember, 1 plus R raised to the power N, right? Or minus 1, right? Minus 1 all over R. Then depending on whether it is annuity due or ordinary annuity, you know what to do, right? That is the future. But here we are saying the PV is equal to...
Annual investment is left out, the X.
Oh, yes. There is X here, right?
Yes, sir.
There is X here. Thank you very much. So, and here to the formula, is that okay?
Yes, please.
Yeah, and this one is the same thing. You see, this formula that you have, assuming the thing is, this formula assumes that compounding is just 1 year. But what if the compounding is plenty? It means you need to put T here, put T here, put T here. So that is that. You need to take note of that. Then this one too is the present value of an annuity. So this one, I can call this one the future value of an annuity. So you can call this one future value A. So let's rewrite the formulas. Okay, so future value A is equal to X into bracket 1 plus R over T when the thing is compounding more than 1 year. You see, that's the formula. It's just that when it is compounding annually, T will be 1, so you don't write them. All right. So that is that. And you have here NT minus 1 all over RT. So that is when the compounding becomes plenty in a year. Now this one too, who knows the formula for and the annuity formula, the normal annuity formula for the PV? You know that it is actually this, you see, 1 minus 1 over 1 plus R raised to the power N. The the PV formula. This is the PV formula. So 1 minus the PV formula all over what? R, just like this. But when the thing is compounding annually, let's say the number of times is compounding, here will be over T, here will be over T, here too will be over T, multiplied by T. All right, so basically that is that. All right, guys, hold on. Let me come, make a U-turn and come. All right, are we okay with the formulas?
Yes, please.
All right, so please ask for the formulas. They are formulas. I'm not young. Okay, so there are times you have to use this formula, and there are times you have to use this formula. But whenever you are using the future value formula, just make sure to understand whether it is annuity due or it is ordinary annuity, so that you know what to do. And the dynamics of whether you are future valuing the thing another 1 year or you are PVing it back another 1 year. All right, so please take note of that. All right, so that is very, very, very key. When do you use PVA formula and when do you use the FVA formula? You see, the PVA formula is about the fact that, and please, this formula, I think I missed something. There is X here, right? Or the PMT. All right, so you can call it X, the same X that is here, the same thing. All right, so that is that. Same thing. All right, so you need to appreciate the fact that there are times that you have to use this formula. There are times you have to use this formula. You see, when do you use this formula? We use this formula when we want to, the money is in future terms, okay? Future. So find out in the question, are they asking me something about the future? Or they're asking me something, if they're asking you something that is about now, so this one is now. And when I say now, I told you now also means what? Today, okay? Year zero. Immediately. Advance. So these are the words that you should know. All right, and these are the ones that you look for when you are doing future. All right, so the same thing, the PMT is the even payment or even installment. This is the same for the X, all right? Then the I here is the interest rate, okay? So please take note of that, the interest rate. Then the M is the frequency. This M, please, I have changed the dynamics. I use the R, I didn't use the I. So you can decide to go anywhere you want to go, all right? All that matters is you understand the variables. Then the N is the number of time. I put T, all right? I put T here. My T is the number of time the thing is compounding in a year, all right? So please take note of that. All right, so that is that. We are going to use this formula to be calculating sinking fund and future value. So basically, this is all what this part 10 marks is about. How to calculate the effective interest and how to calculate the final values or the present values of our annuity. So that is the major area in this. That is where your exams is all about. All right. So another thing is the sinking fund, and it zooms into the same thing. You see, the sinking fund is looking at if you know, I don't know how many of you understand the contingency fund Ghana has and how money moves from the contingency fund to the sinking fund. If you have done public sector, you should have an idea about it. But the sinking fund is a fund containing money set aside, all right, save to pay off debt of bond. This is what our government of Ghana is supposed to be doing. They should have some fund. And in that fund, we should be depositing money into that fund, even amount. So if it is 5% on the, please, those of you doing public sector, how is the sinking fund in Ghana funded? Is anybody here doing public sector? Or you've not gotten to that place?
So we are done with public sector.
Oh, so sinking fund?
Yes, please.
Do you know how much or any percentage of Ghana tax revenues or any monies that goes into the sinking fund?
Not really.
You've forgotten. But the idea is that there has to be some amount set aside, all right, so that we will be using it to service our debt. Unfortunately, this government spend the money in the sinking fund. So when the debts were due, we didn't have it to pay. And so they attribute everything to COVID and Russia-Ukraine war, that it brought hardship, so they had to use the money out of the sinking fund and all those things. But the truth is that any money that is used out of sinking fund will have to get the approval of Parliament. So for them to have used the money, it tells us that Parliament approved. And please, I know we are doing financial management, but I always do this in every class that I teach. Please be careful who you vote for as your MP in the next coming election. I don't care who you vote for as president, but I care who you vote for as MP. And for those of you who are doing, okay, me MPP ni intima tuama Akufo-Addo intima mentoma ne MP no, be careful. You see, we are living in a nation where we've been brainwashed, and you vote for maybe Akufo-Addo, you are convinced to vote for the MPP person alongside him. That thing is very, very dangerous and very, very bad. It means that the two of them, both the Akufo-Addo and the person that you are putting in Parliament, can connive and kill the nation. It's as simple as that. The only way they can spend the money out of the sinking fund is when Parliament approves. Herein, if MPP has the majority, it's a matter of yeah. But have you sat down to analyze when MPP is the president and the NDC is the majority? Do you know how it will be like? It will take the thing to make sense for it to be approved. Yes, and that is what has happened to us. I think as part of them spending these kind of monies and doing anything, that has caused one of them to die, because he had to be present to vote the yeah. So he had to move from the hospital to come and do yeah. Then that was the end of his life. They say it is not because of that, but if he has stayed in the hospital, don't you think that the doctors would have cared? They tell you that he was going to die already. I mean, do you know that? And because they needed that one man to override the NDC number, he came, he's dead. So please, guys, you guys are learning. There is no point in learning all these things and becoming a chartered accountant, and the nation is hard, and you don't see a sunfasobia. There's no point. Tell your parents, convince your families. I'm not saying tell them to go and vote for party A or B, but tell them to critically analyze the person. Men vote to parliament. Economy hard. Who is suffering? You and I. So please show that you have the sense in you. Don't let them come and vote for me, and now vote for you. They can destroy your life, as simple as that. And you will be left in the churches praying that God should come and deliver you. When you were choosing them, did you pray to God that you were choosing them? After you are coming. So please, let's be careful. Let's make wise decisions. That thing is at the forefront of my heart. Let's make wise decisions. For me, I don't care who you vote for as president, because me, I see the president as having no power. A president is like an MD. It's a decorator's name. Any donkey can be a president. Yes. But the parliament, or Shembram Wediso, If the parliament is good and the president is a donkey, the parliament can take away the president. So please be careful. All right. So back to sinking fund. So there is a specific amount that you are supposed to put into the sinking fund. Now, that sinking fund is not just money that will be there. They will be using that sinking fund money as investment. And herein, the investment will be also generating interest, which will be compounding. So it's just the same thing. So it hovers around. Now, depending on whether you are looking for is here or here, this part becomes the sinking fund. This is it. This X is the sinking fund. So look at what I've done here. I said that to calculate the fixed amount to be set aside to build the required amount of interest. So here you are always seeing that you will be paying some debt in the future, some loan in the future. So you want to know how much should you be putting there, X, annually, so that when the future comes, you will be able to pay your debt. So that is that. And so that is what the sinking fund is about. Putting the money in here so that in future you'll be able to pay the debt. So that one is purely a future value. So I said that what do you do? Make X the subject in the annuity formula in case it is future value of annuity, and make the PMT, which is this X, all right, in the case when it is the PV of an annuity. So that is all that you do. So the sinking fund is just about this X. All right. So that is that. Anyway, so that is majorly it. There is this question, but this question, I want you to analyze it carefully. In fact, I would want to give it to you as an assignment, and I expect you to get a different answer from the answer that is here. If you really understand the concept we are doing, you should be getting an answer I believe should be different from the one that is here. Watch this question. If one wants to invest equal amount into a bank for 5 years, starting from, this is the date, starting from this date, in order to have the following amount, 1 million for the purchase of a land in this date. So if I were you, if you really understand what we've been doing, this is a typical case of the person starting the investment at the beginning of the year. All right. So he's starting, but we will need to read further. Let's read further and finish. So he wants the money that you say so that he can buy a land in this date and also have enough to buy an annuity of 240,000 per annum for 4 years, commencing from this date. So this is another date. So this date is actually a 1 year on top of this one. So this date is 2017. This one is 2026. So when you do your annuity, it means that the answer that you have gotten here, if you want to bring it back to the amount, to add it up to this 1 million in 2026, you need to do what? Push it back 1 year. You need to do that. Or you can also decide to push this one front 1 year so that you can get this one. So be careful. I need you to understand those things. Now, the question is that, is it ordinary annuity or it is annuity due? Now, watch this. He says that how much will F1 need to deposit at the end of each year in a fund to generate the return of 10% per annum compounded annually. So my question to you is that, is it ordinary annuity or annuity due? Yes, ordinary annuity or annuity due?
Ordinary annuity.
Ordinary annuity. Okay, that's fine. So you realize that, in fact, you see, this is what they have. So the purchase of the land, the 1 million there, we know. But this one is the annuity. So this is it, an annuity. That's the annuity, PV of the annuity, because the annuity is starting from 2017 back. So we need to do it and PV it back. So we do it, we PV it back, and by so doing, this is what we've done. So this one, we PV it back to 2016. So this is it. So together, this is the general amount of future we need. Now, if you found this, then you can do this. You apply your ordinary annuity. First, you need to find the amount, the total amount that he needs, because the total amount is in two. One is 1 million. I don't know if you see it. Where is the 1 million? This is the 1 million. And not only 1 million, a 240. This 240 is an annuity. So you have to do an annuity of this one. And the annuity formula is this. Okay. This is normal PV in annuity, so that you can bring this money that is in 2017 back in 2016. All right. So 2026, sorry, from 2027 back to 2026. Now, when you do that, this is what you have. Now, when you finish your answer, and that is why I wanted you to calculate it, you can go through it. When you finish your answer, you realize that when is the person taking the money? At the beginning, right? This is it. What you did brings you here. But like we discussed, the person is making the payment at the beginning. At the beginning. So he's taking the money at the beginning. So your ordinary annuity at the end of the day puts you at the end of the year. So it means that when you are done, you need to PV this thing back 1 year again. And that is what you see here as the money being PV'd back 1 year. So if you really understood what we've been doing, that is it. That is it. Okay, so that is that. Any question? Because you have to go and try your hands on this using the understanding that you've gotten. Please, the timing schedule is very important. Okay, the timing is important. So at the end of the day, that brings us to the end of time value of money. There are past questions you need to go through. I'm going to solve. Let's do this one. The rest, you do it as an assignment for me. I'm not sure we may meet tomorrow morning. I'm not sure we may meet tomorrow morning. So let's, yes, please.
Please, I have a problem with my phone. So it's on and off.
And then spend time and watch the recording.
So please, you have not put me on the Telegram.
But the Telegram, we gave the link for everybody to join. It's not like I put somebody there. It means you didn't join. That's the meaning.
Okay.
So I now need to go and look. I now need to find your contact on my phone and try and add you.
Oh, okay.
Yeah. So it's your own disobedience. But I'll add you. Don't worry.
But tomorrow, will you have class at dawn?
That's what I'm saying. I'm not sure it will happen.
Okay. Thank you very much.
You're welcome. Yes, Emmanuel. Awesome.
Yes, sir. I'm not being added to the Telegram when it comes to the FM.
Really? But when it comes to which one have you added?
The FM, I've not been added.
I said, you said when it comes to FM, and I said, when it comes to which one have you been added?
Financial reporting have been added. Public sector have been added. And then man accounting too have been added.
Yeah. Have you been joining this class? Or today is your first time?
Today is my first time for
so I don't even know you are in this class.
Oh, okay.
And so I don't think you can force me plenty like that. I'll add you. No problem.
Okay.
And the person, please become mute. You have some feedback. Ima, please mute.
Okay.
The person who first said I've not added him, what's your name?
Rampa Koshiaba.
Oh, senior man himself.
Rampa.
Is that Rampa?
Hello. Yeah, Rampa Ava.
Amma.
No, Rampa Ava.
Ava.
Rampa.
Please,
Yeah, Rampa.
Confirm. I've added the two of you now.
Oh, okay. My phone will be going off. So thank you.
All the best.
No.
All right, let's look at this. Let's crack this question. Then let's solve the 2019 question. Then we part way. Look at this question. And please, it's always 10 marks. This part always comes for 10 marks. So pay attention. And you need speed in also calculating this part. It says that Joy Mummy Limited is establishing an endowment fund to finance a scholarship scheme to provide funding for education for children of its employees. The company plans to make initial deposit of 500 into the fund now. The initial deposit will be invested for 3 years before any disbursement will be made from the fund. So it means that you make deposit, this deposit will stay there for 3 years before any withdrawal and disbursement will be made. The effective annual rate of return on the fund is expected to be 14% in the first year, 15% in the second year, and 16.5% in the third year. Compute the balance of the fund at the end of the 3 years. Any idea? Yes. How do you think we do this? If you really understand this part, it's bonus questions, so you can do it and get your marks free of charge, then you move. Yes. Yes. Who is ready? Magafu, can you help? Or you have to be typing. Yes, Ima, your hand is up. Or it's from the old time.
With this one, I think that you use the various interest rates. There's a various interest rates to calculate for each year because they are separate interest for separate years.
So do it. You show me, like, say how we are doing it so that I write.
So the first year, the initial deposit, which is the current year now, so the rate will be
what is the rate?
The 14% in the first year.
Mm-hmm.
Yes, so that's
so how much is it?
Yeah, just a minute. 14%. So that will be 70,000.
70. Guys, yes. You should be confirming.
14% 500.
Yes, please.
Then what happens? Then what happens? Please continue. Fast. Hello?
Yeah, so just a minute. I want to get my figures right.
Oh, please, somebody should also help because I don't know what you want to get right from these two figures.
Please add the 500,000 and the 70,000.
So that was 570.
Yes, please.
Yeah. So what do you do again? Yes.
Then 15% on the 570.
15% on 570. You see, if you're able to get this part, that is all the examiner trying to trick you. That is all. You see, the problem is people going to compute it on this one. If you're able to figure this one out, that's all. We did compound interest. And you see, there it says that the initial deposit will be invested 3 years into the fund. And they told you that they will never remove the money from the fund, any money from the fund till the end of the year. In some of the questions, they will tell you that he will withdraw some. So if in case this one, he will withdraw 100,000, what would you have done? 100,000 in the second year. What would you have done? So check the dynamics of the question. You see, we cannot teach you everything. There are some of them you have to apply common sense. We cannot tell you, go into the nitty-gritties of the examiner's mind. We can't do that. But you have to know that some of the things are common sense. He can tell you that the person will withdraw 100,000 at the beginning of the second year. He can also decide to tell you that the person will draw 100,000 at the last day of the second year. He can also decide to tell you that the person will withdraw 100,000 in the middle of the second year. So you should know the dynamics of these things, okay? That one is purely common sense. You apply, then you're able to achieve that. So when you do the second year, the rate, how much will you get?
85,500.
85,500. So how much becomes the money? Yes, what do you do again?
So when you add, you get 655,500.
655. So we're 500, 5500 like this.
Yes. Yes.
So then it means your third year will be 16.5 on the same, right?
And the 6555.
Yeah, how much will you get?
You get 1081.
1081. 8157.
Yes.
Like this.
Sir, please wait, please.
Oh, please, he's not the only one in this class, and I really don't appreciate
108,157.5.
108,157.5. That's all. So why will you be there like that? Yes. So how much? The question is, how much? What is the balance at the end of the third year? So what is the balance?
763 658.
763
658.
657.5 or 58, whichever way you want to do it. Now, please, we are the formats. Adding, adding. How many minutes will it take you? How many minutes will there if you really know what you are doing? You are supposed to. This is a 10-mark question. You are supposed to use 30 minutes to answer each 20-mark question. Which means that this one you are also the 15 minutes and A and B way. A and B way. So it's way this part. We 3 minutes. So please, how to punch your calculator is also another thing you need to learn. And this is a finance class. Finance, they just say you need to know how to punch calculator. Now this is the question of interest. This is where I'm interested. Uberton Limited is offering 5 million units of 15-year bond with face value of 100,000 each. All right. Though the bonds are being offered at a price of 95 cedis each, the bond will be redeemed at a premium of 10%. The annual coupon rate of the bond is 15%. Interest is payable at the end of every 6 months. a provision in the bond indenture requires that Oberty Limited establishes a sinking fund. You remember sinking fund? To accumulate enough money to pay the redemption amount. Please focus. To pay redemption amount. Sinking fund. Redemption amount upon redemption or upon maturity. To comply with this provision, Oberty Limited plans to set aside an even amount at the end of each quarter over the next 15 years. Each of the even amount will be set aside, will be invested into at an annual interest rate of 12% with quarterly compounding. Now, first question you need to always ask yourself is that which of the two formulas is applicable in this question? Is it the PVA or the FVA? So answer me, which of them is applicable in this question? Yes. Yes. In fact, I'm not going to wait for some of you to be silent. You said what?
Future value amount.
FVA.
Yes.
Yes. In fact, everybody will talk. Emmanuel, your hand is still up. Please, which of the formulas? Into Unima no account the anthem. Like, is it McAfee is the one that said the FVA, right?
Yes.
So Christabel, Julius, Stephen. Hey, we Splendarin. Or how do you mention that? Splendarlin.
Yes, it's me, Ebenezer.
Splendarlin.
Bona. Yeah.
Splendarlin. Okay. Oh. Please answer. Yes. Stephen. Yes. FVA or PVA? Christabel.
FVA.
FVA. That is Stephen. Okay. Splendarlin. You see, some of you are not concentrating. No? If you want to join, I don't know for Emmanuel, your hand is still up.
Yes, sir. FVA.
FVA. Okay.
Yes.
Ebenezer speaking. Splendarlin. Future value of annuity.
Okay. Julius Smith.
That is a FVA.
That's the meaning. No problem. All right. No problem. So FVA. All right. That's fine. Now, when you know that it is the FVA, the question is that which of the FVAs? So because when it comes to the FVA, we have ordinary annuity and we have annuity due. So which one is that?
Ordinary annuity.
Let me say ordinary.
Ordinary. Okay. So if it is ordinary annuity, then we know that the FVA is equal to S into X into bracket what? 1 plus R, right?
Yeah.
Over N. Here T. Here T. There is -1, right?
Yes, please.
-1 all over R T. So something like this. All right. So the formulas are the same anyway. There is not much difference in the formulas. Okay. And I think this one is like this. The X is inside, right? So it's actually something.
What you quoted is correct, sir.
The
X is outside. It's outside the bracket.
All right. So we had 1 plus r raised to the power n, right? So because the number of compounding, we need to do it minus 1 all over r t. So that is that. That is that. Now we need to find this future value. The question is actually asking us how much the person should be paying, right? Uberty Limited's plan to set aside. So calculate the even amount that should be put into the signified at the end of each quarter. So it means that we are looking for which variable? Which variable?
X.
X.
Yeah.
So we are looking for X. If you are looking for X, then it means this one is known. So how much is this one? So that is where the thing comes in. It says that we want the future, the final value of the to pay the redemption amount. What will be the total redemption amount? Who can calculate the redemption amount? Who knows how we calculate this one? Yes, the redemption amount. Because that's the future value we are looking for. 5 million units, 15 years bond, face value 100. Though a bond are being offered at 95, the bond will be redeemed at 10%. Premium. Coupon rate is 15%. Yes. Who can tell us how we do that? Those of you who have passed FR, you know IFRS 9, have you? You know how we calculate these things. What are the components of a bond? What are the cash flows of a bond? We will be doing it anyway when we get to financing decisions. What are the cash flows of a bond? Yes. All right. So whilst we wait, the cash flows of a bond are the interest and the principal payment. These are the cash flows for any debt instrument. So here we are told that the principal is 5 million units, which has a face value of 100,000. And though, and these are English, though the thing is, so they are trying to tell you that the face value of the thing is actually 95, but it is being sold at 100. And again, we are still paying another premium on top. So it means it tells you that this is 5 years. So year 1 to 5, you'll be paying interest. Okay, so year 1 to 5, how much will be the interest? Interest is 15%. And please, these are future amounts. So there's nothing like present value. We want future amount. You people told me that we want the future amount. So you are not going to do any PV into present value. You still want the future amount, which means that you'll be doing the principal, the 15% multiplied by the face value of the thing, which is 5 million units multiplied by 100. So it means your interest will be 15%, and it's 5 years. So it means every year you will be paying for 5 years. So 500 million. How much will you get? Multiply by 5. How much will you get? So every year, 5 years. So normally this is how, normally this is how we present it. So years, we have 1, 2, 3, 4, and 5. 5 years. But on the 5th year, you'll be paying the principal cum the interest. So normally we repeat the 5 years twice. So you have interest every year is how much? 15% of the 500 million is how much? Guys, point calculated. 75. So every year you'll be paying 75, 75, 75, 75 for 5 years. Then on the last year, you'll be paying the principal, but they told us that you'll be paying the principal cum premium. So it means that you'll be paying 1.1 times principal. So how much would that one give you? You'll be paying a premium. Premium means something on top. If you don't understand premium, then it means you don't go to bank. Sometimes you go to the bank, you are joining a queue. Some people will come, they will walk in straight. Bufuna Kobisa is a premium customer. It means that he's on top of you. So premium is something on top. So it means the 10% premium means you need to calculate 10% on top of the value. So how much is that? Which is 550, right?
Yes, please.
550 million. So when we do it like this. So when you add all these things, how much is the future value then? How much will be the future value?
925.
Please, somebody should confirm. You should confirm.
I want to ask a question. In the year 5, when you calculate the premium, and then okay, you separated the 75,000 from the 550,000. I was thinking we could have added both.
Yeah,
that was what I wanted to find out. Okay.
You can, in the whole year 5, you can actually add.
All right. Okay.
Do I have, I've served you this question, right? This manual, I've served it to you. Is that not it?
Yes, you have.
Yeah. Okay, let's move on. I hope the figures you are giving me is correct, because it sounds new to me.
Yeah.
Yes, so what is the total?
Is that one I added? I also got the 925,000.
You said 900 and what?
25,000.
925,000. I'll confirm. But as it stands now, I'm taking your words. All right. If this is our future value, then the rest of the work is not a problem. Is it? So we put it in our formula.
Sir, please, a question.
Yes, please go ahead.
Sir, the 1.1, are we supposed to multiply or raise it to the power of 5 years?
Which one are you talking about?
The premium that we...
No. It's the 10% on the value. Then you add it.
Okay.
But so what you've done for me is correct, Abby?
Yes, please.
So you said 925,000 is equal to X into bracket 1. And what will be the rate? This is the rate that we are giving, 12%. Okay, annual interest of 12%. So 1.12, right? Let me draw it well.
Sir,
yes, please.
Can you also go this way, that you multiply the units, that's the 5 million units, okay, by the face value, which is 100,000 times the premium.
Times the premium.
Yes.
But that is what we've done.
Okay, but if I think when you do it that way, you wouldn't get the 925. I don't know why these ones are giving us 925.
Okay, so hold on. We have 5 by 100, right?
Yes, 5. Yes.
This one, this 5 million by 100.
Will give us.
To
give us
that, yeah, so
500 million.
They told us the redemption, the total redemption value, not the total amount, not the entire principal, not the entire interest is not part. The question restricted us to only the redemption value. So the redemption value is what we are looking for. That's why I said the figures looks off. So we need redemption value. So the redemption value was actually the last part that we were doing. So this one will give me 500 million.
Yes.
Then the redemption value, it was raised by 10%, right?
Yes.
Premium.
That's the premium factor.
So 10% on the 500 will give us what? 50.
Yes.
So the total is what? 550. So this one is the redemption value. Yeah, but what you did was the entire amount. But the question said that the provision of the indenture is that they should establish a sinking fund to accumulate the enough money to pay the total redemption value, not the interest. So it means interest is not an issue here. The issue is what? Redemption value. And this is what we have. That's the redemption value. So that 550 that we did here, this one, this is the only one we should be concerning ourselves around. All right. So this is the 550 we need to use now. So the future value is 550. So 550 is equal to, we have X, then into bracket, we have how much? The rate is 12, so 1.12, right? Raised to the power, how many years? So
raised to the power,
like this. No, it's wrong. This one should be 1 plus 12% is 0.12, right?
0.12.
All over, how many times is it compounding in a year?
4. That's 4 quarters.
4. Yes, 4. Raised to the power, how many years is this thing for? 15 years.
15 years by the 4 quarters.
Multiply by 4 quarters. Are you getting it?
Yes.
The number of times it is compounding here. So once we get that, we do -1 all over R, 0.12 over 4. Yes. So now compute it and give me the final answer.
$163.05.
163.05.
Yeah, 163.05.
Like 163.05.
Yes, please.
Is it millions or something? Okay, this thing we did was 500 million. Check it well. This thing is supposed to be 5 million by 100. So when you are writing, write it well.
Okay.
550 million. I wrote 550, but there should be actually another 3 zeros.
Okay.
Yeah, there should be another 3 zeros.
So you write it well and just hey, who's that? You might think your network is bad. Yeah, your machine, it gives some feedback, but I think when you talk, it's just the feedback. So did you all get the same answer?
Yes, sir. 163.05.
No, I don't think it will be 163 point. You have to quote it in proper terms.
That is with the.
Or you put million
multiplied. Yeah, million. Yeah, multiplied by the X. So it's multiplied by the X.
The top here only. You've not divided by this side.
No, please.
No, please.
I want final answer. Now say the mommy there. I said the way I was fine.
Okay. Sorry.
I said
answer is
then 3
million.
Okay. Times million. Okay. Wow.
Hey, the figure I'm getting here.
Yes.
Hey, is these people calculating this thing correctly at all?
337,319.
Is that what you are all having?
No, please.
Is that what you are all having?
No, please.
Yes, I had the same.
So if you have something different, give me your own. We will check right now.
So I chat you. Check my way.
It's
3 million. It's 3 million.
Figure I've actually written here.
Okay. Yeah, that is the figure. It's 3 million.
Don't worry, I'll confirm.
Okay.
Because Hello, Ima.
Yes, sir.
Please mute for me. There is feedback from your end. Please, those of you quoting 3 decimal places, stop that habit. This is money. Pesos ends in 2 decimals. $3,373. I'll confirm your answer soon. For me, as a tutor, I'm interested in your process. Sincerely speaking, I'm not really interested in your final answer. But you should show the process. In fact, you should show the process to which you get your final answer. And those are the you know, in your exams, we really don't mark your final answer. I hope many people don't know, but it doesn't say don't write, but you write your final answer. It's just that is not the center of attraction. It is the process that is of essence. All right, so I'll confirm your answers because I've been solving this question for a while, and I think I have the solution in my. All right, I'll confirm. But guys, so that is what we do when we are trying to understand the time value of money. I think you can pick up the next years and try your hands on it. All right. So you have to ask yourself the questions and later really understand how you end up using the right formula so that you can end up getting the right answer. Okay. So the answer is actually 3,373,127.31. So this one is correct. All right. So that one is correct. So at least that should. Let me ask you this question before we go. Just a quick one. So this one is saying that Odapejan is borrowing 5 million and 500,000 to finance a project involving the expansion of its factory. It has obtained an offer from Sika Bank. The terms of the loan facility are as follows. Interest rate is 22%. The duration is 2 years. The interest method is compounding interest with quarterly compounding. So, and your payment plan is equal installment at the end of each quarter. So they said that compute the quarterly installment. And this one, they said that prepare the loan amortization table. So I think, let me see, maybe tomorrow I will meet you for just 1 hour. It's possible. But if I don't, please try as much as possible to solve questions. And next week, if I don't meet you, God willing, tomorrow, it means that the next week, the Friday, we will have to solve questions. So solve questions on time value of money as per our timetable. Because the reason why I may not meet you next week is that I have a class at UCC to teach in the morning. So the class we do it 2 is 2, so it means that this Saturday I need to go there, but the following Saturday I don't have that class. So maybe it will shift to the next Saturday. But I want you to tell me this before we go. So which of the formulas, just the A part, I part, which of the formulas is applicable in this one? So Odapejan is borrowing. Is borrowing to finance a project. It has obtained an offer. So they're giving us. So first of all, which is it, PVA or FVA? Yes. PVA or FVA? Or you want me to call names? Emmanuel. Yes, FVA. Guys. You said what?
FVA.
FVA. Okay. Yes, anyone with any different?
I think FVA.
FVA. You are Spenderlin, Abi?
No, Ebenezer.
As it stands, you are Spenderlin.
FVA.
FVA, Julius.
Yes, sir.
The ladies have not spoken.
Yes, I said FVA.
You who?
Christabel, I said FVA.
Okay. Then, so everybody has spoken. Stephen and Makafui.
This is FVA.
FVA. Okay. Then one last person, Abi. By Imakasa. Makafu, you are the last person, so that we go.
I am thinking it's PVA because they are saying he's borrowing, like, as in the statement. To me, I think the statement means he's borrowing the money now.
You are the one we should vote for to become MP. All the others are here. Yeah, so I gave you the words. So you should be able to spot that. And you see, that is what makes this part of the exams confuse students. So their ability to distinguish which formula is applicable. So you see, he's borrowing the money now. It's not like it's a future money, it's a future thing. We want a figure in the future. And as a matter of fact, he has even obtained the offer. So it's not like it's a future stuff. He's saving money to get an amount in the future. Or he knows the amount in the future and wants to know how much to save to get to that amount in the future. So there is nothing futuristic here. Everything here is now. So if it has said that Mark Odapejan is borrowing so and so amount in future, and normally in those ones too, you will see the years. Like the one we just did, 15 years ahead of us is the redemption. Okay, but this one, if you say future, which future are we? How many years is he in how many years' time is he going to borrow the money? So you need to be careful. You need to be careful, because when you think that part, just everything you be doing there is you are wasting time. That's the meaning. Only your mom sorry, you are just wasting time. So please, it's not that simple. Okay, your ability to fish it out is very, very important. So you can, once you know the formula, that the rest is mathematics. Another one too is here. Let me see. This is the last one. There we go, please. So look at this cash option, and there is a credit option. So it's the same thing, the same thing we've been doing. It says that the option requires an immediate payment of full price of plant. If PDS chooses this option, it will pay a cash of this one today. Then PDS plans to raise the required amount by borrowing from a bank. Consolidated Bank Ghana has offered to lend PDS at an annual interest rate of 15 with monthly compounding. Oh, you see. So this one, the T will be how many? 12, right? 12. The loan interest and the offer charges are amortized evenly by even installment of this each month, each made at the end of each month over the 3 years. So the question I'll ask you right now is that this one, for instance, which of the formulas apply? But please don't be confused by this. This part is already known. What you need to know is this part. This one is today's value. So you don't need to find a PV of it again. It's already in today. You can't do a PV of an amount today again. So this part will be down. Then there is another portion of it that he will have to be paying this amount. So the question is that, is it a PVA formula or an FVA formula for that option? Then the option 2 reads around the same. So you are going to solve all these questions for me. And please, those of you who are developing the habit of not solving the assignment, God will bless you. God will bless you. Yes. Because last week when we met, I gave you some theoretical questions you are supposed to do for me. You people decided not to do it. Only one person sent me the solution. So for all of you, in fact, God will bless you.
Almost done. You have it by tomorrow.
Sure, by tomorrow. Now, and then I class, See, I'm a very tight person, sincerely speaking. I won't lie to you. I'm a very tight person. And so Sika Nimo. Sika Oh, but you see, one thing I sacrifice for is these things. When you send me your solution, you see, when you are asleep, I'll wake up trying to go through your solution to give my remark. And I told you, I have my boss on this platform. My boss is on this platform. Yes. And he can tell you how busy I am. Like, he knows. And he knows that, in fact, I have a lot to do. I also have a presentation and some research assignments to work on. And that form, sir. But I still would take time and go through your work because you have paid money for it and I can't take it for granted. Yes. So what they also say one if he say I should force you when I know I'm a busy person. No. Why should I create job for myself? Until there's also one God will bless you. That's the best I can say. So please spend time and go through it. And please be genuine, be sincere. It is good to get it wrong so that the tutor will know that we're in a formative evaluation. I don't know students need 80. It tells the teacher that do it again. But if you don't do it and everything looks, they understand. Then at the end of the day, bam, that's it. So please, and let's repent, Let's repent and do the right thing. So who is giving me the answer so that we close, please? Oh, but the symptoms in the questions are clear and obvious. So,
present value.
It's what?
PV.
Okay, Yachiwatu.
Dan.
And I mean, can't wait now. I come and do it. You see, black man's life. That's correct. Anyway. That's correct. And I look to now too here.
No,
we got to explain now. Can you explain?
Oh yes, please.
Okay. So please try your hands on the assignment. So the amortization table, for instance, I know this is amortization table. So let me give it to you. So you need the balance brought down. You need the finance cost, which is the interest calculation. All right. Then payment. Then here will be balance carried down. So when you do it, when you find the money, and please, they said something, they said quarterly. So it means in 1 year, you have 4 periods. So in the 2 years of that question, you have 8 periods. So 1 up to 8. Okay, so you divide the money into 4 quarterly in 2 years. So that is that. So the interest to divide it quarterly. Then the payment is what you are working for. The payment is what you are working for. Compute the quarterly installment. So when you work it, then you put it in here. As for the balance, this is the balance. It starts here. You borrowed 500,000. So you do the interest. What is the interest? 22%. But since it is quarterly, it will be 0.22 over 4. So you apply it and get your figure here. The answer that you will get, you put it here because it is already quarterly. That one you won't divide. The answer that you get is quarterly. So you put it here. All right. Then you do, payment is always deducted. You do the money plus the interest minus the payment, then you put it here. Balance carried down becomes balance brought down here. Then you repeat the process up to the end. Okay. So, ladies and gentlemen, that brings us to the end. My lecturer will say the entire kaboom. All right. So I'll put on your platform if you meet. No, we can't meet tomorrow morning. We can't. So let's meet on Friday. And I have extra video we have done on this. So I'll put the 2 on your platform. Today's what we have done and that 1 too on the platforms, just so that you can watch and get more understanding. So God bless you guys. And in fact, I really enjoy this class. All the classes that females are inside, all the other classes now so yeah. All right. So guys, have a great evening. Okay.
Thank you very much.
All right. So I'll put the videos on your platform right now.
Yes, please. Thank you.
All right. Ima, you have a question?
Yes, please. I've not been added to the man accounting Telegram.
Hey, me chairman accounting. Hey, pressure man. Me chairman accounting, no. Me financial management. Call your man accounting lecturer, please. I beg you. All right. Thank you, guys. See you.